Hey everybody, I'm gonna make a couple of short videos that you can watch separately to kind of help us learn this section 2.2. We just can't get to campus to cover it. It's not going to be on our first test, but it is the first time we're going to talk about how to model using data sets. And so it's really important because it continues to come up through all four of our modules as we study new functions. So right now we've really just talked about lines and linear functions. So we're going to be looking at data sets and trying to get a model because they behave in a linear fashion. So let me show you what I mean. I'm going to start with a data set. Typically, when you're doing this kind of regression modeling, which is what it's called that we're doing today, you start with a data set. You go and collect some data on your own, or you have some data that has been collected already for you and you want to analyze it a little bit. And in this instance, this is just a typical example. I would like to know if there's any kind of relationship between how long you study before a test and your predicted test score based on how long you studied. Okay, and so this is easy to collect data as long as you get people to tell the truth about how long they studied. But this is just for 8 students, so I have it broken up into two separate tables. If we were in class, we were going to be doing this in pairs, so that's why I broke the table up. But really, we have a data set of 8 people where we asked how long they studied, and then we measured the score in their tests. We'd like to see if there's any kind of a pattern or a correlation, any kind of relationship between the two, meaning if one of them increases, does the other one follow some kind of pattern based on that? So the easiest thing that we do when we're doing modeling, first step, is we take our data sets and we assign one to be input and one to be output, and then we graph them and create a scatter plot of individual points that are pictures of our data set. So I have gone ahead and started this. So I took these 4 um, students' data and graphed them as these couple of ordered pairs and did the same thing where I put these two together into these ordered pairs. And let me show you what the graph looks like. In the interest of time, I'm going to have a did the graph. So here is a grid of X, Y values, and we've got the hours studied. I had those assigned to be the X values, so I have that running along the bottom. So these numbers are for hours. And then at the side, I have the test score, which would go from, it looks like we've got it going from like 50 up to 100. So these are the 8 points if I graphed them all together. So this point means that that student studied for 3 hours and their score was 85. So you can get 2 pieces of information from each data set. So when we look at all of this data together, you take a look and say, is there a pattern? There might not be a pattern. If there's not a pattern, it just kind of makes a cloud. It kind of looks like just a mush of numbers. It doesn't have any kind of pattern to it. But this does seem to have kind of a basic pattern that as the hours of study go up, the scores tend to go up. It's not perfect, of course, but we can see they generally tend to have an uphill trend. Okay, and so even though they can't all be fit on the same line, there's no curvature to it. It doesn't look like it peaks and then it starts to fall or vice versa. It does seem to have not much curvature, just in general, just kind of march up this line. So the model would be, we're going to assume that this is a linear type of behavior overall, and it may not be a perfect linear behavior, but it's going to be close enough to where we could probably write a line, an equation of a line that could kind of fit through the bulk of those points the best. Now, since obviously there's no line that's going to fit all of the points at the same time, we want to try to choose or find a line that, while it may not hit any of the points exactly, if it misses some points, there's going to be some points that are low and some points that are high. You don't want it to be too top heavy or bottom heavy. So right now, the only way we know how to get a line is to just pick a couple of points and then do some of our algebra and find the equation between those 2 lines. But you want to be careful which 2 points. So like if I wanted to pick these 2 points, for example, because they're right next to each other, if I tried to find the equation of the line between those 2 points, let me just give you an example. I'm going to put my ruler over those 2 points. That's what that line would look like. Well, it fits those 2 points very well, but look, it misses all the other ones by quite a lot. In fact, the whole trend on this one is downhill. So it doesn't even fit the general uphill trend. And most of the points are below this line, and we have 1 point that's way above the line. So those would not be the ideal 2 points to pick if I had to use information from just 2 points. So let's see if we have another better one. Maybe I wanted to do I don't know, if you look at these 4 points kind of tend to line up together. So if I try to pick a couple of those points and write the equation of the line, it does cover those points up or hit those points almost exactly. But this still isn't the best way to pick a line because the points that it does miss are all above the line. So since there's no errors or points that are also below the line, this line is ultimately not very good because it's too low to represent the entire data set. If those 4 points were the only thing in our data set, then that would be the line that would fit it really well. But because we have these other points that are kind of floating up here above, we need something that's a little higher. So maybe we do the first point down here with the lowest X value and the highest X value, like at the very end. So let me try to put my ruler, but there's our first point and the last point. All right, if I put the point there, and the first point was over here and the last point's up here, those 2 points create this line, and this looks pretty good because it misses 3 points because they're too high, but it misses 3 points because they're too low. So that's getting to be a little bit better in terms of describing the trend of all of the points for the whole set. So that's what I'm going to do. I'm going to pick the coordinates for this point, which is 0.5, and I believe it was 76. And then this point up here, that one studied for 5 hours and they scored a 95. So I have already done that here. So I picked 2 points out of the whole data set, and I'm basically ignoring all the other points. And then I'm going through and I'm doing the stuff we did when we were in class. I found the slope, rounded it to 4.2, put the slope of one of my points back in that point slope form. And this is what comes out as a linear model if I get it rearranged for y. The slope is about 4.2x and the y-intercept is about 74. So remember what that means is that according to this model, if you don't study at all, the average score for people who don't study at all would be predicted to be 74. And for every extra hour that you study, that overall is expected to improve your test score by 4.2 points. That's what that means. So that's something that we could use to model the data set here, but this had 8 data points. And basically we just ignored these 6 points in the middle and just used the information from the first point and the last point, just because visually when I put that line in there, it looked like it fit that area the best. So this is one way that we can do come up with our own linear model. Now, what we had done before that is they would tell us something like, if you don't study at all, you get a 74, and every hour that you study is expected to increase your score by 4.2%. They would give us those two numbers, and we would just kind of form this equation by knowing where to select and where to place those two values. But here, we don't really have anything but a bunch of ordered pairs. So we had to just pick 2 ordered pairs, and I just picked this one again because it seemed to fit through the middle of the bulk of the points the best. And those 2 points give us this line. Now, once we have this line, we can use it like a regular function, and we can use it to make predictions about, we don't have any information here for someone who studied for 3.5 or 4 to 4.5 hours, maybe. Or maybe you want to make sure that you get a B. So if you look at this and here's 80%, we'd want to say, well, how much do I have to study in order to make sure I get above 80%? You could work it like a regular function. So this is what we're doing when we model with data. The first thing we do is we graph the data as a scatter plot and we see if we can see any kind of a pattern or a trend. And then right now, if it does seem to be a linear trend, then we can go ahead and we know how to write an equation of a line just based visually on what 2 points seem to create a line that fits the rest of the points the best. But that's not always going to be all that accurate. It just depends on if you have 2 points to happen to create a line that looks good for the group. So there is a better way, and that's what I'm going to do in the next video, is how we're going to use some computer-aided technology to take information from all of the points to get the very best fit. Okay, so right now, I guess what I'm going to do is I'll take a pencil and I'll just draw in that line so we can kind of keep track of it. And then I'm going to stop this and we're going to go back to, so that is the line that I just got by hand. So that line was 4.2x plus 74. Okay. So that's what this line is. And we just got that from using this point and this point. Okay, so I'm going to stop this video. That's just the idea of taking a linear model from a data set with a goal. We take the data, we plot it as a scatter plot of points, and then we look at that trend of points and see if it looks linear. If so, then we're going to find the equation of that line that we think will fit that pattern the best. Okay, so let me stop that one and upload that one, and we'll come back in part 2. We'll talk about a better way to find that line that uses information from all of the points, not just 2 that we have to pick.